Okay, one more. There's a velocity versus time graph. So what all I'm asking you in velocity versus time graph, what all we can do is what we'll try to find out. Find the total distance covered, total displacement, average speed, average velocity. Okay, there's something. Average velocity. For time t equal to 0 to t equal to 9 seconds. Okay, there's a VT graph. Velocity versus time graph, what all we can find out. First, what is the path? What is the path? This is very important. So I just took person so that you can, in your home, you can experience these graphs. That's why I took person. I would have took particle, I would have took some vehicle or some bike or some any moving object. But I took person so that you can feel yourself as I am moving like that. So that will be easy for you to understand. No, there's a velocity will increase for 0 to 2 seconds, the velocity will increase. Then for next 4 seconds, the velocity is constant. So velocity increasing means it is some sort of, and look at the slope is constant. So what do we get? Acceleration. So there's a uniform accelerated motion. So I wrote here accelerated motion. For 0 to 2 seconds, it will be an uniform accelerated motion. Then for 2 to 6 seconds, it will be uniform velocity motion. The person is going to walk with a constant speed. How much? 4 meters per second. After that, it will change the direction of motion because this is negative. There's a positive, there's a negative. You have to change direction of motion. Then it will move with a 2 meters per second. Then retardation. It will be retardation. If speed will decrease, it will be retardation. Okay, agreed. Okay, now let's get into the calculation part. Now, what is acceleration here? 4 minus 2, a dash. How to calculate a dash? Okay, here I wrote directly. How to calculate a dash? A dash is available as 2 meters per second square. This is acceleration. Then there's a uniform velocity, uniform. This is a retardation. What is the retardation? Retardation will be minus 2 meters per second square. It will be directed towards right. Acceleration directed towards right. Retardation directed towards right. Let's get into where to calculate the total distance covered. So all the areas will calculate A0 to off into base into height. 4 meters. 4. Okay, we'll just only calculating those areas there. Next, A26. A26 will be 4 into 6 minus 2. So this will be 16. A68. This should be equal to, I think, area is negative, minus 2 into minus 4, sorry, minus 4. Next further, A89. This should be equal to half into minus 2 into 9 minus 8. The value of this is minus 1. Just will calculate only area under VT graph. We'll see. So now total distance covered is needed. Total distance covered, you just add up all those areas. For distance covered cannot be negative, no? So E is what? Say, what is the use of this is like you will walk 4 meters with uniform velocity, with accelerated motion. There's a uniform velocity motion. Then again, there's a uniform velocity. There's a retardation. Distance covered 4, 16, 4, 1. Distance covered should not be negative. That's why I'm taking mod. Able to understand this? Why this mod? Distance covered should not be negative, no? So therefore, this will be 4 plus 16 -4 plus -1. 25 total displacement. Four plus 16 -4 -1. 15 meters. What do you mean by 15 meters? Finally, the person will be at a distance of 15 meters. What is the net displacement? 15 meters. I should put I cap towards right, no? It will be. Then after this, average speed. (25/9). Average velocity. (15 I cap by 9). This average velocity. So we know distance covered, displacement, all the quantities is what we are able to predict here. So total we can find out from the VT graph, distance covered, displacement, average speed, average velocity. Then afterwards, there's a part. See, of all, I feel this is very important. If a student is able to draw this diagram, he has understood. He has understood everything. Rest all these are the mathematics you can manage. What actually going on? This is the very important. Okay, now let's go for the other graphs. If I know velocity versus time graph, can I plot acceleration versus time graph? Yes, we'll go for it. First, it will be accelerated motion with 2 meter, accelerated motion 2 meter. Uniform velocity. Then again, uniform velocity. Then again, it's a retardation. Sir, how come this is the acceleration, this acceleration? Look at the thing. Because it's moving with a decreasing speed. So therefore, as the motion is towards left, the retardation is towards right. Therefore, anything that is towards right should be positive. So therefore, what we can conclude here, acceleration can be positive or negative. Retardation can be positive, negative. It all depends upon the direction of motion here. So like we didn't understood that this the way you are writing it. Say like we'll do one thing. There's a vehicle. It is moving with a increasing speed. I'll give this an example. Oh, at least so it was like a 2 meters per second. Now it is moving with a 5 meters per second. What you say, acceleration? This is what you are going to say, acceleration. No? So let me give all the examples. I'll no, let this be V2, let this be V1. Then you are going to say retardation, no? It is. How the retardation? Retardation directed towards left. Here we'll call AA. It can happen that trucks will be moving towards left. V1, this is V2. 2 meters per second. 5 meters per second. Look at now. Now I can say acceleration towards left. No, then it can happen that this is moving with 5 meters per second. Now speed decreases. Now what you should say? Retardation. Look at all this. So what is the comment you are going to put? Acceleration directed towards right. Let me use this snip. This is a retardation towards left. Looking at this third diagram, what do you say? Acceleration towards left. Retardation okay, now look at this. Don't think that acceleration should be always directed towards right. It all depends upon the situation. Please do understand. So don't analyze mathematically here. It all depends upon the situation. The acceleration can be, if anything directed towards right, you should call positive. Anything directed towards left is negative. So based on that, what happens, we can put signs for even acceleration and retardation also. This is something very fundamental. Please do remember. See, everything one has to analyze here, not possible. Just I will accept things not possible. One has to analyze. Justified retardations are why not is negative? No, retardation is directed towards right. So therefore I'm putting positive. So this is in fact acceleration. This is in fact retardation it is. So from VT graph, what all we can do here? We can find out the speed. We can find out the like a distance covered, displacement, average speed, average velocity, even the acceleration or the retardation. So area under the curve will give distance curve, displacement. From that average speed, average velocity. Then the slopes will give the acceleration or retardation. So this much of information is available in the velocity versus time graph. Okay, this is what we have plotted is velocity versus time graph. Corresponding to that acceleration versus time graph. What about the position? Because you see the position of person. If you take this is s equals 0. If you take this is s equal to 0. The position of person is in fact varying, you know. As with the time, it will become 4 meters. Next will cause 16 meters. Then again back 4 meters, 1 meter. So let's plot that position versus time graph. First, accelerated motion. I'll increase the screen size. First, accelerated motion, then uniform velocity motion, then again uniform velocity motion towards left, then retardation. And finally come to rest. So slope here should be 0, here slope should be 0 because he has moved from rest to rest. What is the net displacement? 15 meters, that you can see. Total distance covered, 20, then 5, 25 meters. So if you know one curve, you can bring the all other curves.